So today we will see what are operators in quantum mechanics. An operator A cap is a mathematical rule that when applied to a ket or bra transforms it into another ket or bra of the same space. Like if A cap is an operator applied to a psi ket, it will transform this ket into psi dash. Similarly for A cap applied to a bra phi, it will transform it to another bra phi dash. Operators also applies to wave functions. Let's see how they works. Example, unity operator, that is I cap. So when I cap is operated on psi, it will give you psi back. Another example of an operator are gradient operator, that is del of psi r will give you dou psi r upon dou x I cap, dou psi r upon dou y j cap, dou psi r upon dou z k cap. Let's see the linear momentum operator. P phi r psi r minus I h cross del of psi r. Your del is a this del operator. Let's see the Laplacian operator. Del square psi r is equal to dou square psi upon dou x square, dou square psi upon dou y square, dou square psi upon dou z square. Another type of an operator is parity operator. P cap psi r equal to psi minus r. It inverses the symmetry. Let's see some algebraic properties. Product of operators. Two operators are not commutative. Not commutative. But if you take three operators operating together, they are associative. A A cap, B cap, C cap is equal to A cap, B cap, C cap, or A cap, B cap, C cap. When they operate on an state psi, A cap, B cap, psi r, first B cap will operate, then the resultant state will operate with A cap. Let's see what do you mean by linear operator. So an operator A cap operated on a linear function A1 psi 1 plus A2 psi 2 will give you A1 A cap psi 1 plus A2 A cap psi 2. So as you can see, this operator operates linearly throughout it. Similarly for bra, psi1 a1 plus psi2 a2 operated by a cap will give you a1 psi1 a cap plus a2 psi2 a cap. Similarly, when 4 operator a cap, b cap, c cap and d cap operates on psi, so the chronological order with which they will operate is first D will operate, then the resultant state will operate with C, and that resultant will operate with B and then with A. Also, when an operator operates with a ket and a bra, we get a complex number. Let's see the expectation value of an operator with respect to state psi. It is defined as bra of psi a cap plus ket of psi by. So if your state is normalized, this thing will turn to 1 and you will get bra of psi and ket of psi operated with A. When a ket operated to a bra, we get a linear operator which is in Dirac notation. So when our linear operator is operated on a psi dash ket, we obtain a transformation with respect to phi vector. So when a operator operates on a ket from right hand side or an operator operates on a bra from a left hand side, these things are forbidden in Dirac notations and they have usually no physical meaning. Let's see what is an Hermitian operator. So an operator which is equal to its dagger is called as Hermitian operator. What do you mean by a dagger? A dagger is a conjugate of transpose or transpose of an conjugate of an operator. It can be also written as phi a cap psi equal to psi a cap phi star. As you can clearly see, it is a transpose of an conjugate and both are equal. Skew Hermitian operator is nothing but when a operator's dagger is equal to its negative of the original operator, or you can write it as psi b cap phi equal to minus of phi b cap psi conjugate. Now let's see what is a projector of projection operator. So if an operator is Hermitian and square of it is itself, then it is called as a projection operator. Example of it is unit operator. As you can clearly see, dagger of it is equal to itself and square of it is also equal to itself. So let's see some of the properties of projection operator. So product of two operators which are projection operator is also a projection operator. But sum of two projection operator is not a projection operator. If P1 and P2 are two projection operator, they are gonna be orthogonal if their product is 0. And for P1 plus P2 till Pn to be a projection operator, it is a necessary and sufficient condition that these operator must be mutually orthogonal. That is, the cross product must be 0.